Imagine digging a hole. Not just any hole, but one that goes right through the earth. Picture yourself starting in your backyard and digging straight down. You'd pop out the other side, right? Maybe in a completely different country or even on another continent. Sounds fun, but is it even possible? Could we really dig a tunnel through the entire planet? As much as we love a good adventure, the reality is much more complicated. The Earth is not just dirt and rocks, it's a complex structure. Digging through the Earth is a challenge even our best scientists and engineers haven't figured out. The deeper you go, the more difficult it becomes. Why? Let's dive into the science. Our planet is made up of several layers, each with its own unique properties. Our planet has layers, kind of like an onion, but way hotter. The crust, mantle, outer core, and inner core each present their own challenges. To understand why we can't dig through, we need to get to know these layers a bit better. The crust is the outermost layer where we live and dig. So let's get digging into the science. The mantle beneath the crust is incredibly hot and filled with semi-solid rock. The outer core is even hotter and made of liquid metal, while the inner core is a solid ball of iron and nickel. The intense heat and pressure as you go deeper make it nearly impossible to dig through. Even our most advanced technology can't withstand these extreme conditions. So, while the idea of digging a hole to the other side of the Earth is fascinating, it's a journey that remains in the realm of imagination and science fiction, for now. The Earth's surface, where we live and dig, is just the crust. This outermost layer is incredibly thin compared to the rest of the planet, making up less than 1% of Earth's total volume. It's thin, like the skin of an apple compared to the whole fruit. Just as the apple's skin protects the fruit inside, the Earth's crust shields the layers beneath from the harsh conditions of space. Below that is the mantle, a thick layer of hot, mostly solid rock. This layer extends about 2,900 kilometers deep and is responsible for the movement of tectonic plates, which can cause earthquakes and volcanic eruptions. Even deeper down, we encounter the Earth's core. This central part of our planet is divided into two distinct sections. It has two parts, a liquid outer core and a solid inner core. The outer core is about 2,200 kilometers thick and is composed of molten metals. Both are made mostly of iron and nickel. These metals are crucial in generating Earth's magnetic field, which protects us from harmful solar radiation. Think of it like a giant superheated metal ball in the center of our planet. The inner core, despite its extreme heat, remains solid due to the immense pressure at the Earth's center. Each layer has its own unique properties and challenges when it comes to digging. The crust is relatively easy to penetrate, but the mantle's solid rock and the core's intense heat make deeper exploration incredibly difficult. Let's just say, it's not as easy as digging through dirt in your backyard. The deeper we go, the more complex and challenging it becomes, requiring advanced technology and understanding of Earth's geology. As we venture deeper into the Earth, things get hot, really hot. The temperature rises the deeper you go, thanks to something called geothermal heat. This heat comes from the Earth's formation and radioactive decay happening within the planet. And if the heat wasn't enough, the pressure increases dramatically too. Imagine the weight of all the rocks and layers above pressing down on you. That's the kind of pressure we are talking about. These extreme conditions make it impossible for us to dig through with our current technology. Our tools would melt, and even if they didn't, the pressure would crush them. Section 4. Digging deep, but not through. Humans have tried to dig deep into the Earth, though not through it yet. From ancient times, people have been fascinated by what lies beneath our feet. Early civilizations dug wells and mines, but it wasn't until the modern era that we developed the technology to dig deeper than ever before. The Kola Superdeep Borehole in Russia holds the record for the deepest man-made hole. This ambitious project began in 1970 and aimed to reach unprecedented depths to study the Earth's crust. After decades of drilling, it reached over 7 miles deep. This incredible feat required overcoming numerous technical challenges, including extreme temperatures and pressures that increased with depth. While impressive, that's barely scratching the surface of our planet. To put it in perspective, if the Earth were an apple, the Kola borehole would only penetrate the skin. Remember, the Earth's radius is almost 4,000 miles. This means that even our deepest drills have only explored a tiny fraction of the Earth's total volume. So we have a long way to go before we even come close to the core. The Earth's core remains a distant and largely mysterious frontier with conditions that are currently beyond our technological capabilities to explore directly. These attempts, while not successful in getting us through the Earth, have taught us a lot about our planet's composition and the challenges of deep drilling. Each core sample and data point helps scientists understand the geological processes that shape our world, providing valuable insights into everything from natural resource deposits to earthquake prediction. Section 5. So through the Earth? Not today, maybe not ever. So can we dig through the Earth? With our current technology and understanding, it's a resounding no. The heat, pressure, and sheer distance are just too great for us to overcome. Perhaps in the future, with revolutionary technology, we might find ways to overcome these challenges. But for now, the idea of digging through the Earth remains a scientific impossibility. The Earth, with its hidden layers and extreme conditions, reminds us of how much we still have to learn and explore, even right beneath our feet.